Hello, Calculus 2. There's one idea left in section 7.2, and it's the volume of a solid with known cross sections. Now, when we were doing the disk method, we had known cross sections. We were slicing them into disks, so those cross sections were circles, disks. We called them disks. And the area formula for the disk for the circle was pi r squared times its thickness. So that was the disk formula for the volume of a solid of revolution. But this is for any known cross section, so you end up with the area. Now, if the cross section is running perpendicular to the y-axis, its thickness is dy, and your area should be a function of y's. That was true with our disks that were around the y-axis. Cross sections perpendicular to the y-axis. Cross sections that are perpendicular to the x-axis have a thickness of dx, and you work in x's, and you just need the area formula for a cross section. And it could be triangular shapes or square shapes. Like I said, the circular shapes were the disk method. Was our example of a disk method. So I just want to do one problem, and it's this pyramid. The Great Pyramid of Egypt, actually, the Great Pyramid, constructed about 2500 BC, which is about 4,500 years ago, roughly. And it has these dimensions. It's 481 feet tall and 756 feet long, and it has a square base. That's what a pyramid is, a square base, and these triangular sides. Or that's what the dimensions were originally. So I want to calculate the volume. So I think I'm going to slice it into squares. I think I got a bunch of squares stacked up, and they keep decreasing in area, so their area will be a function of y. I think I'm using this formula because my squares are going to be perpendicular to the y-axis. And I probably will set up an integral from 0 to 481, the height of the pyramid, and I'll try to come up with this area formula and work in y's. These are y bounds, and so here we go. I'm going to just start that. I think my integral goes from 0 to 481. I'm going to need some kind of function of y here. Now, so again, here's the picture of the pyramid, 756 by 756 feet base, 481 feet tall. Here it is when I try to put a y-axis and an x-axis on it and sort of look at it sideways. And so this is what I really need, is sort of that inner picture there. Let's just look at that. If there's my y-axis and my x-axis, and here's 481, here's the height, then this is sort of this half of a length of a base. That distance is kind of what I need. I'll have these, like I said, I'll have these squares coming through here. There'll be a square of a various size coming through here. The one at the bottom will be 756 by 756. The one at the top will be nothing. And in between there, I'll have all these little squares. I'll be adding up their areas. So I think I need this is half the side of one of my squares. If this is 756 feet, then this distance here on the x-axis from the middle of the pyramid out is half that. What's half that? 378 feet. So I can probably get the equation of this line. It's a line that has a slope of down 481 and over 378, negative 481 over 378 times x, plus the y-intercept, which happens to be 481. So there is the equation of the line. What I need is this distance x, that distance x, for an arbitrary square. Well, I could solve for x then. I guess I could solve for x. Solving for x, I would subtract the 481 from the y, move the 481 over, and multiply by the reciprocal of that slope, negative 378 over 481. So there's x. And to tell you the truth, back to my picture, that distance x is half the side of the square. So I really sort of need 2x. So 2x would be 2 of those, which would be the negative 756 over 481 times y minus 481. And then I need the area, which would be that 2x times 2x. You know, the area is that 2x squared. So the area would be that 2x, that side squared, or this formula squared. That's what needs to go in here. The negative 756 over 481 times y minus 481, all squared. Wow. I mean, just setting it up was a challenge. I think I did that right. I'm not sure how well I explained it. I did my best. I'm going to add up all these squares, and that's the area of a particular square. I used an arbitrary distance x, written as a function of y, to set this up. Let's try to do it. So I'll be doing an integral from 0 to 481. I will square that number. It'll be 756 over 481, the whole quantity squared. Since I'm squaring it, I just took off the negative sign. I'll be able to pull that constant out in front of the integral. Then I'll be, but I can leave it there. But then I'm going to be integrating this y minus 481 quantity squared. I was thinking of foiling it out, but I really don't have to. I could do a little u substitution. If I let u equal y minus 481, du is just dy. It's a y. Yeah, so that's just like a u squared. So how do you integrate u squared? Okay, hang on. I got 756, 481 squared out here. I'm integrating this u squared with respect to u. And I get 1/3 u cubed. 1/3 u cubed. The u is y minus 481 cubed. I'm going to evaluate that from 0 to 481. This is awesome. This is awesome. I'm going to move back over here where I got a little room. I'm sorry. I'm moving back over here where I got a little more room. Actually, I think I'll just erase this and go up here. Sorry. All right, here we go. You plug in your 481, and it's interesting. You get 0 minus the 756 over the 481 squared. And now when we plug in the 0, we have a 1/3. So I got 0. I plugged in the 481 and got a 0 minus 756 over 481 squared times 1/3. And now I'm plugging in the 0, and I get negative 481 cubed. Negative 481 cubed. All right, well, that negative number cubed will end up being negative, but that'll cancel out this negative. The answer is a positive volume. It should come out a positive volume. And I'll have 756 squared in the numerator. I have this 481 squared, but I can cancel it with the 481 cubed and leave myself a 481 in the numerator, and all divided by 3. So there's the answer. I'd like to see what that is. Give me just a second. Give me just a second. This is the volume of the Great Pyramid. They probably did this on purpose. No, I don't know. Probably not. 756 squared times 481 divided. 756 squared. Sorry. 756 times 756 times 481 divided by 3. Wow. 916367272. That is 91,636,272
feet cubed. Cubic feet.
That is awesome. All right, the volume of the Great Pyramid. And what's inside, only, I don't know, who knows. Thank you.